Hey, my Zoom people, can you hear me? It's just like react. Maybe like a one of the. Okay, perfect.
I made a joke about
Okay, and I think this is gonna end after 40 minutes, so we can just get started and then we'll get as far as we can. Okay. So TA review, Professor Reese finalized the test and she said these are kind of the details of it. It's 28 questions, 5 free response, 4-hour time limit. She said it's not supposed to take you more than an hour. She just set the time limit so that it's taken in one sitting and it's worth 100 points. Is that everything that was on here? Okay. Okay.
Morse code.
Yeah. Wow.
I'll share this screen. Okay. Okay.
Sweet.
Yeah, let's just go into this.
Seems like there should.
What we're gonna do is try to make this a little bit more interactive. So we're actually gonna put a data set in the Slack. Send the. We'll see the data set in the Slack and we're gonna kind of code with you so that you can kind of see. So we can just kind of talk about the data set and go over it. But okay, so we'll just start with some of the data set overview and subsetting. We like this graph. I don't know if that's helpful, but okay. This is some of the stuff that we can do when we're doing data set overview, and we can go through these. So, I'm going to start in a new Colab file. You'll just need to do your own because we haven't set one up yet, and you'll need to use the file that is on in the Slack. But we're just going to import and what are you guys? Are you guys are gonna need NumPy and Seaborn? Import and import. Okay, run that. And then we're gonna get going with this data set.
This is pretty easy. Welcome to. This is 4:15 QA.
Yeah, could be.
Better be good. I hope so. How you feeling about it? Visiting?
Ryan. Sweating like a shit. I feel.
Sorry, I lost it. Okay.
Sure.
So that's the data file for those that want to follow along. We're gonna use a data set that's about jewelry.
So interesting.
And so we're looking at some categorical data, which is like our cut, color, and clarity, and then some numeric data, such as the depth and the price, and then the length, width, and depth and carat. So that's kind of the data that we're going to be going through when we do this. So we'll start with some of the subsettings. Just to remind you what some of these do. If we do like df.shape, we can see the columns and the rows that are in the data set. We can do df.head. Who can shout out what this one is gonna do?
First 5 rows.
Beautiful, love it. And you can also do df tail and it'll give you the last 5, or like df head 10 and it'll give you the first 10 rows instead of 5, but it'll just default to 5 when you just do df.head. df.info, who knows that one?
Data types.
Good, love it. It shows you data types, null values, basic information from the data set like that. We can do dot describe. You know that one.
Yes.
Then
Yeah,
off.
you, Catherine?
Do you mind zooming in just a little bit? Screen, I'm so sorry. It's not on.
Yes.
How can I do that?
Yeah, there you go. Is that better? You'll see that? Yes. Okay. df.describe will give you for all the numeric data, some of the data types. Or not data types, the yeah, this is and there will be a couple others that we'll cover later. There are other things that you can do when looking at just default information about your data set. So you can look at like, trying to think of which one's categorical. We can look at like all of the cuts of the diamonds. So we can do df cut dot unique, and we can see what the values are in that one. So that's something else you can do. You can also do actually yeah. Okay, so that's some of the basic overview stuff. There are also things we can do when we're subsetting data, like looking at comparison operators and logical operators. Does anybody know what the difference between comparison operators and logical operators is? Guess. A comparison operator is when we are looking at specific numerical attributes, and logical is when it's like a full statement. So one of the first ones we can look at is the comparison operator of less than or greater than. So we can do things in the data set like looking at we'll do price. We'll say if the price is less than less than $300, those are the kind of values that I want to return, and there aren't any, so I'm gonna make that higher, say 350 maybe. Yeah, so this comparison operator will return anything with that attribute where the price is less than 350. A logical operator we can do where, let's say we do the same thing. We want to look and see all of our diamonds that are less than $350, but we also want them to be of a certain cut. So we can say df cut is say premium. And I did that wrong. Yeah, so that is two comparison operators with where I do the equal value and the less than, and then it's a logical operator in the middle that connects the two and makes them fit together. So that's kind of the difference of those. And the last comparison operator that is on the study guide is in. So that's just one where we can say, I want to look at the values of cut. That is in, and then I can add more than one, which is why you would do this. So we can say ideal or premium. And so then it'll return for me all of the diamonds that are either ideal or premium. As you can see, they're listed out. Yeah, so that's the that's an overview. Any questions on any of those? Okay. Oh, yeah.
Yeah, I'm just curious, do you think, and I'm not sure if you're allowed to say, but will the term be kind of, hey, which of these syntaxes is correct, or will it more be, what does this do? Maybe both.
We haven't seen the midterm. Yeah. I
Did the review, it had questions that was like, which of these lines?
Haven't looked at the review.
There's a review.
I would say no grades, no syntax, no when you're supposed to use like parentheses over like brackets. No, like how Lizzie showed, like when you would do and or, like how you would do that in syntax.
But it's probably not gonna be like tricky questions where there's something missing in one.
It would, yeah, it won't be tricky.
Okay.
Yeah. And for those of you that don't know where the review is, if you go to grades and scroll down to like exams, it says optional next to it. It wasn't in the schedule or anything. And so that's probably why a lot of you didn't know where it was. But yeah, look over that and then the study guide. We have not looked at the midterm. Katie said we should not.
But she said
Before this.
She said there shouldn't be anything surprising on the midterm if you've gone over the study guide and the practice exam. Yeah.
I'm sorry, within exams, it's where?
I think it's at the bottom.
It's the practice midterm.
Yeah, it's like it says optional.
Okay.
That's all we need.
Yes, definitely take that before you take the midterm, because I think they'll be pretty similar. I think Katie told me that a lot of she made the review and the test together, and then she kind of the questions for both. So it'll be very similar to the review.
Andy's gonna do data cleaning.
Awesome.
Just to clarify, the first example was a logical operator and then the next two were comparison operators. Is that correct?
Look at that.
What's the interval? Version is.
I don't know how to get rid of that. This one, the is a comparison operator. This is a logical operator because it has the and, like the and the or.
So it's average of these.
And this one's also a comparison operator, yeah. So it's comparison logical then compared.
They're gonna be taking. Sure.
Yeah, there you go. So I have speed doing it. Okay. Data cleaning. Okay, so this is everything from the study guide on data cleaning. So we're gonna go over it in lab file. And yeah. Okay, I'm just gonna show you guys the code. We'll go over it. I'll probably ask a few of you to explain what the line means. And so first of all, run this. Okay, so we're gonna look at the data set that we have. We already looked at that. We already looked at info. So with data cleaning, we want to ask, is there any data types we should change for this data set? And the data set for this is already pretty clean, but one that we may want to change is price, because price, if you have like cents after it, then you'd want the decimal, you know? And so to change a data type,
you're going to do this code right here. So you're gonna do dot as type, and I'm gonna change the price column to a float. And you can do that with the other data types too. With the flow, you can do integer, I think. But yeah. Any questions on that? Yes.
Could you also zoom in just so like.
Yep. Sorry, guys.
Run.
Once. Any other questions? Yes.
Can you maybe just go over verbally like what the circumstances are for different data cleaning things? Like if it's really small, you just delete them, right?
Yeah, so we're gonna get to that.
Oh, okay.
This is just for converting data types. Does anyone have any questions on that? I'll get to that. Okay, so let's say we want to convert a data type, but this is an example from an airline data set that you guys have worked with. Let's say the delay minutes has 30 minutes and 15 minutes, but you want it to just be the number. So you're going to take the delay minutes and do string.replace minutes to just this empty. And that will get rid of the minutes, like the text in the column, and leave you with just the like 15, 30, whatever. Then you can do this up here, where you change it from it would be object to a. Any questions with that line of code? Okay, next we're gonna do grouping by keyword. So we're gonna ask what columns can we simplify? If you guys remember one of your in-class activities, I believe it had a data set with a column that had different types of like bread and cheese and yogurt. There was like French bread, wheat bread, blueberry yogurt. And that's something that we can simplify into just like bread, yogurt, cheese. So for this, we're going to simplify the cut rankings to good, better, and best. Awesome. And so here you're going to define the category labels. You want it to be good, better, or best. And then you're going to find the patterns for the function or whatever to look for. And so for good, you want those to be either the fair or the good cut diamonds. For better, you want them to be ideal or very good. And then for best, you want it to be the premium diamonds. And then right here, you're going to be building conditions. And this string.contains, it's going to go through and return either true or false for like every row, if that makes sense. And so if it goes, we'll get that down there actually. And then you're going to apply all the code at once. And you're going to do this np.select. Does anyone know what this np.select does? Anyone want to take a guess? Yes.
I'm gonna assume that it's going to take in your rankings, which you defined up above, the conditions of how to rank them, and it's going to return this column, which is just a list of true and false.
Yeah, exactly. It's almost like, I like to think of it as like an if statement. So it's going to go through and say, if it's fair or good, has that in it, then it's going to be good. And if it's ideal or very good, it's going to be better. And if it's premium, it's going to be best. So it does that all in this one line. And if it's none of those, it's going to say it's other. And so then .describe, we already went over that. We learned that the top one, better, which means the ideal or very good were the most common in the data. Okay, any questions with this right here with grouping by keyword? Cool. So now we're gonna go over the missing data, and this is the less than 5%. Okay, so for this, we're gonna go by this line by line and kind of explain what each line does. So what does this line do? Okay.
It's getting the length of the data set and then doing 5% of that, and that's your threshold to see if you're gonna take it out or leave it.
Yeah, exactly. So this is gonna give you back a number. And what you're gonna do is if anything is less than that number, you'll drop it. Okay, what about this line right here?
It gets the columns you're gonna drop that are within a threshold.
Yep, exactly. And then this line right here,
It's just like, yeah.
which one's a little trickier. Oh, admit. Admit. Oh, okay. Yeah,
Oh, you're gonna do the data frame. You're gonna drop, subset equals is it's asking for which column to drop, and we've already made a variable that we're just gonna drop those columns. And in place true means that the data frame itself is actually being changed.
yes, exactly. So just to go over that again, drop NA is going to drop the rows with missing data in a column. And the subset equals means that we're only going to look at the columns that we defined right here, which is those columns that are less than the threshold. And then in place equals true means that it's going to change your original data frame, your DF. And so you don't have to go back and do a bunch of other stuff. Okay, any questions with this block of code right here? Yeah.
Can you explain what the less than equal to threshold is doing? Is that making it so? Yeah, just explain that.
Yeah, so this right here, you're taking the columns and then it's going to look at columns that have null values in it. And then it's getting the sum of those null values. And then if it's less than or equal to this threshold that we set right here, which is going to be 5% of all the columns in the or all of the rows in the data set. If it's less than that, then it'll drop it. Does that make sense? Yeah.
Why do we need the subset? Could you not just do calls to drop, or is that just a syntax thing?
So subset, that means it's only going to look at these calls to drop. If you do drop NA, it will look at all the rows, I'm pretty sure. So if you have, let's say you have a column that has more than 5% missing, it's going to look at like all of those as well and drop columns, which can be too much and it can make your data set like not have enough information to do accurate data.
So, but like you can't just do calls to drop. You can't just put that variable there.
I don't think so.
I have a question about, so are we dropping the columns or are we dropping the rows in the columns that we care about?
So you're dropping the rows in the columns that have less than. You're not actually dropping the actual column. Because then you would be dropping 100%. So. Any other questions with this? So what if our column has more than 5% missing? This is from the airline example again. And so you're going to do what's called like imputing data. And so you're going to take those null values and put a number in there to make it have a value to it. And so you're going to, with this example, is the gate airport size. You're going to group by airport size, which is like large, medium, or small airports. And then the gate change count. So this is going to be an integer. And so you're going to take the median of this gate change count and it's grouped by airport size. And then you're going to take it and put it into a dictionary, which is going to look kind of like this. So for large airports, the gate change count median is 10, 6, 2 for small. And then you're just going to go in and fill in the missing data with these medians right here. And you can also do like mode, if that makes more sense for your data set. Yeah. And so, yes, what's your question?
Yeah, I know in class we talked about you could put the median, you could put 0,
Mhm.
depending on the data. How do we know what if it's better to medium is put 0?
Good question. So that's when you're going to look at the interquartile range, and we'll get to that a little bit later too. The other ones. And let's say your data is super skewed left, then you're probably not going to want to do average because it's going to be a lot lower than what happened. So then you would probably want to do like the mode, because that's the most common occurring thing. Size outliers. Good question. Anybody else have any questions? Oh yeah.
What does the dot map again do?
That's a good question. I don't know. I'm gonna look it up then.
Column, or do fill and is the one in Norton.
Hey, if no one has any other questions, I think that's all I have, because we're gonna go over interquartile range and more outliers later.
6 with it's taking the dictionary.
I don't think you'll need to know dot map on the exam.
How do you know? You haven't looked at it.
That's right. If you miss that question, talk to me. No, don't kidding, I told you.
Signs.
Okay, it's like the words.
Okay.
Okay, we're gonna do a univariate analysis. These are some of the different functions you can run to do numeric analyses. So you can measure the center, mean, median, mode, and you can look at the spread as well by looking at standard deviations, min, maxes, and the range function, shape of distribution and skewness with some of those bar plots and skewness as well. And then we'll also, actually, we'll just start with numeric. Okay. Why do I keep doing that? Okay. So let's see. When we start to do some of those numeric ones, we can do like if we're looking for, let's see. Let's say with price, because I know that one's numeric, we can go and find just dot mean. And we can do the same with median and mode, and it will just print. I guess we could print that nicer. That doesn't matter actually. And it'll give us the mean. We can do it with median. And then when we do it with mode, I know it will print a zero, because sometimes there could be more than one mode. But when we want to look at just the one, we can say 0 at the end and it'll just print. And it'll just print the one value, the mode. I don't think you'll need to know that for sure though. Okay. When we do, the other thing that's on here is looking at ranges and interquartile ranges. So if we're looking at just, I'm just gonna copy this and make this easier.
Do the same.
When we're looking at the range, we can do, whoa.
I just made it.
I'll use this. There we go. We can look at caret.max minus caret.min, and that will give us just the range of the data. And then we can also find the interquartile range by looking at dot quantile and then putting in the 0.75 and then doing the same with the bottom one. So we can say quantile 0.25 and then there get the interquartile range. So that would be our IQR there. And I've gotten a lot of questions about finding how to know if your outliers are okay or not within the interquartile range. So we'll just walk through that really quick. So if I have my IQR here, my IQR is 0.75 minus 0.25, which is 0.64 was it? And then if I do IQR times 1.5. Then I get this value that is 0.96. So then what I do from there, when I have that value, is I say, rent DF. I can look at what the minimum value is. And then so yeah, I want to start with the maximum. And then I also need to look at what my quartile 5 is. Quartile 0.75. And then what I do when I calculate it is I see, okay, this is a good example. So yeah, we got the interquartile range and then we multiply the IQR by 0.5. So we went from 0.64 to 0.96. And then what we do is we look at this value that is the quartile 5, which is 1.04, and we add the interquartile range times 1.5 to it. So 1.04 plus 0.96 is 2, which is less than my max value. So anything that's above 2 in this data set would be considered an outlier because it's above that. And I guess for another example of one that works, I can do this. I see that my bottom quartile is 0.4. And so I would do 0.4 minus the 0.96, and that's going to be like -5.6 math, which is less than the 0.2. So anything on the bottom is not an outlier because my minimum value is 0.2. Does that make sense? Yeah.
Yeah, that makes sense. Where do you get the 1.5 though? Like the IQR?
That's just always the rule. So to determine outliers, we just take the IQR, multiply it by 1.5, and then that's kind of a fair gauge of what's going to be a fair value in the data set. Yeah. Yes.
Could you kind of explain that again, or like type it out, like what you just did with that 0.96 to find the outliers? Could you type that out?
You just want to see it again. I've got it right there. I just did the IQR, quartile 0.75 minus the minus 0.25 to find what my interquartile range is, which was 0.64. And then I just multiplied that by 1.5 to get the 96.
I mean, what do you do with the 9.6 or 0.96? I mean,
And then from there, I just use the 0.96. So I look at the bottom quartile and then I subtract the 0.96 from that or add it to the 75th percentile to see if my min or max are outside of that range.
so if there's any difference.
Yeah. Yes.
So if I add 96 and 0.4, then I've got 1. And then how do I know if that's in or out of what range?
You know what I want?
Inside and outside of the IQR times 0.15. So I wonder if drawing this would be helpful. Sorry, people on Zoom. So if I've got a graph that has a normal spread, I know. This is probably going to be my interquartile range because this is 0.25. It's going to be smaller than that, 0.75. So then when I get the value of interquartile range times 1.5, it just shows me how far above this value and how far below this value I'm allowed to go before I'm going to hit outliers. And that. And when we graph it, let's see. As we keep going, we can. Let's do more on this. I did. Okay. So we can graph it too as part of the looking at numeric. Values. Let's see. Well, that was it. And when I graph it, I can see that. So. My median is probably like right here. And so all these values that like get way up here probably are outliers. Visually, you can see that, yeah.
You scrolled up just a little bit more. So to interpret these results, anything that's below the 0.4 is an outlier.
No, sorry, I feel like this has gotten too confusing. That is the 0.4 is the quarter percent.
So anything below that times 1.5, or how do we find the outliers from?
If you wanna go to mine and scroll down to the bottom. There's all that. I've also thrown this collab file into the Slack, but this will give you the lower bounds, the upper bounds, and then a line of code to help you find the outliers.
We run this to see what the results would be.
Column name, I don't think we ran anything.
Yeah, just click the run all at the top.
A lot of them are not on the div and.
That's why we're in.
But if you like change like the column name, like what
Column name
columns from
to-
the data set.
Or if you copy this over to your data set. Just, I guess if you just print out all the values, just help us interpret step by step of what it's looking like.
I should have just changed them all there. I didn't think about number two. Oh, this computer. There we go. Okay.
I'm printing down.
So it's all of these values.
If you print out the lower bound and upper bound.
These are all gonna be upper bound, but we're seeing that anything with a caret above. Data set.
Is that the same thing that you just explained, it's written out differently?
Yeah.
I don't think you played the jobs.
I'm gonna keep going for sake of time, but we can come back to that at the end if anyone's still. Okay. So we graphed it there and we can also do box plots. We're gonna move on to categorical just for a minute. There are different things you can do in categorical. Frequency tables where we just do DF and then value counts and then finding the mode and doing count plots. So we'll just do one real quick. DF the cut and then we can find that value counts to get the counts of all of the categorical how many are in each of the categories. And then we can also do a count plot where we do. It's gonna fill that for me, that's nice. Where I can see just that same thing now. So I think that's everything that you really need to know about univariate analysis.